video too. This is one situation where the easier situation, at least to me, is the word problems kind of write themselves. You can find that start value, you can find that growth factor, and to me, it's an easy equation to write. When you're given ordered pairs or tables, sometimes it's a little bit more difficult. So let's go through. Recall that linear functions, you'll see a constant rate of change. Exponential relationships are not going to have a constant slope. That's why we have to do average rate of change. Back when you did that in in Unit 3, we talked a lot about rate of change. Instead, they're going to have a constant ratio. Just like in Lesson 1 of this, when we were doing geometric sequences, you were looking for what's being multiplied each time. That's an exponential growth. So for this, what I need to see is this is going up by 1, -1 to 0, 0 to 1, 1 to 2. So my x values are increasing by just 1. I need to see what is happening to my y values. When I go from 1.5 to 3, what am I multiplying by? So I can tell then that I'm going 1.5 times 2 is 3, and 3 times 2 is 6, and 6 times 2 is 12. If you can't tell, because sometimes you will have weird ones that are more difficult to tell, then just like in the geometric sequences, you can take that second term and say 3 divided by 1.5 or 1.5. And when I hit enter, it tells me 2. So that tells me what that common ratio is, or what that multiplier was. So if I'm going to write an equation for this, my start value, I'm going to go to the y, to the y-intercept, which is right here, when x is 0. So my a is going to be when x is 0. And my b is going to be the whatever the multiplier is. That is your common ratio. So I am thinking that the equation for this is going to be y equals 3, because that's when x is 0, times 2 to the x. Now if you want to check yourself just to make sure nothing funny is happening here, then pick a random one, like pick this 2 and plug that in. 3 times 2 to the 2 power, well, 2 to the second power is 4, and 3 times 4 is 12, which is what I expected. So that gives me, you can, pick a couple and just make sure you got it right. But this is my exponential function. All right? If you can't find a common multiplier, if there's not a pattern that you can follow there, like if instead of multiplying I'm adding, or the pattern is some other weird thing, then it's not exponential, and you can't write an exponential equation to represent it. So let's see if this one's exponential. When I look at 20 to 10, it looks like I am dividing by 2 or multiplying by 1/2. 10 times 1/2 is also 5. 5 times 1/2 is also 2.5. So this is exponential because I have a common multiplier. My starting value is going to be right here when x is 0. That's going to be my a. This is going to be my b. So for y equals a times b to the x, I'm going to put y equals 20 times 1/2 raised to the x power. Again, you can check yourself, plug in a 3, make sure it gives you out 2.5. All right, you guys go ahead and try a couple for yourself, and I'll see you back on the other side to do some half-life problems. Bye!